Hello everyone. So this is a problem from the engine force analysis. So the problem is given like this. It is a horizontal gas engine at 210 rpm, has a bore of 220 mm and a stroke of 440 mm. The connecting rod is 924 mm long, and the reciprocating parts weigh 20 kgs. And when the crank has turned through an angle of 30 degrees from the inner dead center, the gas pressures on the cover and the crank sides are 500 kilonewton per meter square and 60 kilonewton per meter square respectively. And the diameter of the piston rod is given as 40 mm. So then we have to determine the turning moment on the crankshaft and as well as the thrust on the bearings. Okay. So first let us write down the given data. So he has given the speed, that is 210 rpm. So from this we are going to find out what is omega. That will be 2 pi into 210 by 60. So which will be 21.98 radians per second. Then it has a bore of 220 mm, that is cylinder bore, that is cylinder diameter d is equals to 220 mm. It means if I write this in meters, this will be 0.22 meters. Then it has a stroke length of L is equals to, capital L is equals to 440 mm. So, so we know that stroke length can also be written as 2 into R, that is crank radius. 2 into crank radius is equals to 40 mm, and the crank radius will be 220 mm, that is 440 by 2, or this is 0.22 meters, right? Then after that, when the crank has turned through an angle of 30 degrees from the inner dead center, so he has given theta is equals to 30 degrees. Here, theta is equals to 30 degrees, that is a crank angle. And then he has given the gas pressures on the cover and the crank sides as one is 500, the other one is 60. That is, let P1 be the pressure on the cover, that is 500 kilonewton per meter square, and let P2 be the pressure acting on the crank sides. That it is given as 60 kilonewton per meter square. Okay, and then the diameter of the piston rod is also given, which is 40 mm. So diameter of the piston rod, that is small d, is equals to 40 mm. So that means in meters it will be 0.04 meters. Okay, 0.04 meters, small d. So this is a given data. So from this given data, we have to find out what is turning movement, and also what is the force, the thrust acting on the bearings. So these two things we have to find. Okay. So in order to find out these two relations, we know that T is equals to Ft into R. Okay, and the pressure, the thrust on the bearings is equal to F, that is piston effort multiplied by cos theta plus phi divided by cos phi. Okay, so these two relations we are going to use for finding out the what is required: turning moment on the crankshaft and thrust on the bearings. Okay, so now let us find out each unknown one by one. So here from this diagram, first let us find out the thrust on the bearings. Okay, or let us find out what is Ft, uh, because we have to find out the turning moment on the crankshaft first. So let us find out what is Ft first. Okay, so we know that Ft is given by Ft is given by F is into sine theta plus phi divided by cos phi. Okay, so now first let us find out what is F. So S is equals to Fp plus Fi. Fp plus Fi. So what is Fp equal to? Fp is equals to P1 A1 minus P2 into A1 minus A. P2 into A1 minus A. Okay. So then this is equal to, what is P1 here? 500 into 10 to the power of 3 into A1 is 5 by 4 into 0.22 square minus P2 is 60 into 10 power of 3 into, again this is pi by 4 into 0.22 square minus small a is the area of the piston, that is pi by 4 into piston diameter is 0.04 square. So when I simplify this, I'll get the Fp value as this. It is 16795 newtons. 795 newtons. Okay, that is the value of Fp. So similarly, if I find what is Fi, so Fi is the inertia force, so which is nothing but minus m into a. Okay, minus m into a. So what this minus sign represents here is that is Fp is acting opposite to the accelerating force. Okay. So now this is equal to minus m into a is nothing but the acceleration which is given by omega square into r into cos theta plus cos 2 theta by n. So when I substitute all the values here minus, so the m mass is given as, in the question, the mass is given as 20 kgs. Reciprocating mass weighs 20 kgs. So that is m is equals to 20 kgs. So minus 20 into omega square is 21.98 square into r is smaller is 0.22 into cos theta. What is cos theta? Theta here it is 30 degrees plus cos 2 theta will be 60 degrees. divided by n. So what is n here? N is a ratio of length of the connecting rod by radius of the crank. This is n. Okay. So how much is L given? Small l is given, that is length of the connecting rod. So the length of the connecting rod is given as 924 mm. Okay, the length of the connecting rod, that is small l, is given as 924 mm. So convert this into meters. So it will be 0.924 meters. Okay, so that's substitute that here in this relation. So that substitute L is equals to 0.94. Small r also we have determined, that is 0.22. So if I substitute both here, so then I will be getting the Fi value as minus 2094.01 newtons. Okay, that is the value of Fi. So then, so now from this I can find out what is piston effort. That is piston effort equals to Fp plus Fi. So what is Fp here? We got 16795 and minus Fi is 2094.01. Okay, so after subtracting these two, the piston effort will be 14700.99 newtons. Okay, so that is the piston effort. So now once you got the piston effort, we have to find out what is Ft. So for finding out Ft here, if you see, for finding out the Ft here, we should also require this phi value here. Okay, we require the phi value. So let us find out how can we find out this phi value. Let us see. So just I am drawing the spreader crank, that is reciprocating engine. This is the connecting rod and this is the crank. So the crank has a radius of r and it has a length of L. Okay, so let us say the angle subtended by this connecting rod is phi and the angle subtended by this crank is theta. So now here at this point A, I am dropping a perpendicular like this. So name this point as B. So when I drop a perpendicular, so this will be divided into two triangles here. Okay, so one is this one. So let us say this point as C and this point is D. So it has divided into two triangles when I have dropped a perpendicular here. So one is ABC triangle, the other one is ABO triangle. Okay, so in the triangle ABC, sine phi can be written as AB by L, that is opposite by hypotenuse. Okay, similarly in the triangle ABD, sine theta can be written as AB by R. Okay, so now compare these two equations. So when I compare these two equations, I will get L into sine phi is equal to R into sine theta. Okay, so now from this find out what is phi. Substitute all values. Small l is known to us, which is 0.924 into sine phi equal to small r is also known to us, that is 0.22, and into sine theta, that is theta value is also known to us, that is 30 degrees. So substitute all the values and find out phi value. So after substituting the values, you will get the phi value as approximately 6.84 degrees. So this is the value of phi, 6.84 degrees, right? So once you got the phi value, now you can find out the Ft. So Ft is equals to piston effort multiplied by sine theta plus phi divided by cos phi. Okay, so substitute now. Piston effort, how much you got is, that is 14,700.99 into sine theta is 30 degrees plus 5 is 6.84 degrees. This is divided by cos 6.84 degrees. So by simplifying this, you will get the Ft value as 8876.59 newtons. That is the value of Ft. So now you can find out the turning moment. So the turning moment is equals to what? Ft into R. So Ft is 8876.59 into R is the radius of the crank, which we got as 0.22. So then this will give you the turning moment as 1952.85 Newton meter. Okay, so that is the turning moment. Okay, now let us find out the thrust on the bearings, the second one. So this is the first one which we have determined. The second one is thrust on the bearings. So thrust on the bearings is given by piston effort multiplied by cos theta plus phi divided by cos phi. Cos theta plus phi divided by cos phi. Now piston effort is 14,700.99 into cos 30 degrees plus 5 is 6.84 degrees divided by cos 6.84 degrees. So then after simplifying, the value of Fb will be equal to 11,848.33 newtons. Okay. So this is how we have to solve the problem in an engine force analysis of a reciprocating, of a horizontal reciprocating engine. Okay. So thank you everyone. Please like this video and subscribe so that I can upload more videos on the other topics. Thank you.